Lake Champlain is an extraordinary natural resource nestled between New York, Vermont, and Quebec. But the lake and its tributaries are being negatively affected by human activities on the land. Lake Champlain Sea Grant works to develop and share science-based information to improve the environment and economy of the Lake Champlain Basin.
Monitoring water quality at beaches is important to help ensure the safety of swimmers. Lake water is sampled regularly to check for presence of harmful bacteria or other pathogens that may be present in the water as a result of things such as faulty septic systems, manure spills, geese or duck overabundance, swim accidents, or malfunctioning wastewater treatment plants.
It's not practical to monitor for every kind of harmful bacteria or pathogen that might be found in beach water. So instead, we use what are called indicator organisms, which are easy to collect and test for. And they still give us a glimpse into if a beach has been polluted by fecal matter. The most common kind of indicator organisms used in fresh waters are called Escherichia coliform, otherwise known as E. coli.
E. coli live in our guts and help digest the foods we eat, supplying us with necessary nutrients, and sending what isn't necessary off as waste. Therefore, if E. coli are present in the water in high concentrations, there is likely a source of fecal contamination in the water. Luckily, most strains of E. coli are not harmful to us. Instead, they are necessary inhabitants of our guts and the guts of all warm-blooded animals. They serve as indicators of fecal pollution because the more there are of them in a water sample, the more likely it is that harmful bacteria or pathogens are present. Collecting a water sample to assess a water body for bacterial contamination is a straightforward process. Gather the required supplies, including waders, gloves, sampling bottle or bag, marker, and a cooler with ice before heading to the monitoring location.
Once you're at your site, if you'll be sampling from the water, put on waders, disinfect your hands, put on latex or nitrile gloves, and then label your sample bottle and the cap or your Whirlpack bag with the site location, date, and time.
Move slowly into the water to about knee deep. Allow the water to settle from having been stirred up by your movement. Open the sterilized sampling bottle, taking care not to touch the inside of the cap or the bottle. Reach out towards deeper water from where you are standing and turn the bottle upside down so the opening faces the water. Plunge the bottle into the water. Immerse it to about elbows depth and move it in a sweeping motion away from it. To complete the collection, turn the bottle upright at the end of the sweeping motion and bring it up out of the water swiftly. Pour off a little of the water so the bottle is filled only to the shoulder. This allows for the sample to be gently mixed. Gently place the cap on the bottle and rinse. Pour the sample out behind you, away from the sampling location. Repeat this process so that you rinse the sample bottle and cap 3 times. The 4th time you fill the bottle, again, pour off a little of the sample so the bottle is filled only to the shoulder, and then firmly cap the sample. This is your collected sample.
Immediately place your sample in a cooler on ice, and if you're delivering it to a lab, be sure that you get it there within 6 hours of when the sample was collected.
Complete your data sheet with all required information. It is critical to include date, time, location, and the name of the person sampling on the form. It is also important to note field conditions such as weather the previous 2 days, current weather, and site conditions. It is a good idea to use pencil to complete your data sheets, as that will hold even if the paper gets wet. If possible, print your data sheet on Write in the Rain paper. Finally, protect your data sheet from your sample by sealing it in a Ziploc bag.
Now that your sample is collected and your data sheet is completed, deliver or ship them to the lab where your sample will be processed. Your results will be available 18 to 24 hours after the lab has processed your sample.
A result of 235 or greater CFUs, or colony-forming units per 100 milliliters, represents an exceedance of the state standard for fresh water in both Vermont and New York. CFU is a measure of the number of bacteria colonies that grow when the sample is cultured in the lab. This cutoff point represents that about 8 out of 1,000 people will show signs of illness if swimming or immersed in water that exceeds this limit. A challenge with the available testing procedures is that results are not available until the next day. As such, we only know tomorrow if the beach was safe today. A general guideline is this: if there has been a rainstorm within the past 2 days, there is greater likelihood that water will have higher bacteria levels. You can also check websites for the state or municipal beach to track past beach closings, as many will use a longer-term average of sample results, generally determined over a 30-day period.
Lake Champlain is a natural treasure. We all have a part to play in protecting it and the waters that drain to it, now and into the future. This video was produced by Lake Champlain Sea Grant, a partnership among the University of Vermont, SUNY Plattsburgh, and the National Oceanic and Atmospheric Administration. To learn more about Lake Champlain Sea Grant and to see other videos in this series, please visit our website.